بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Math grade 7. We are in model 10 probability. Today we want to continue lesson 2, relative frequency of simple events. Relative frequency of simple events. In the last lesson we talked about experiment and likelihood, relative frequency, and relative frequency tables and bar graphs. And today we want to continue experiment probability from relative frequency. Listen please.
Experimental probability from relative frequency. Teaching notes. The relative frequency of an event can be used to predict the chance of that event occurring in the future. The chance that the future event will occur, based on the experiment's results, is called experimental probability. It has the same ratio as the relative frequency. Select each card to learn more about experimental probability.
So experimental probability is a ratio of the number of favorable outcomes to the total number of outcomes. The symbol B. B means event. B means event. الحدث أو الاحتمال. The rule will be equal number of favorable outcomes over total number of outcomes. So the notation B event means the probability of an event. So B means the probability of an event.
Teaching notes. Suppose Amelia is presented with two unmarked boxes of the same size. Amelia opens the first box in which there is A present. She opens the second box in which there is no A present. The relative frequency of selecting a box with A present inside is 0.5, or 50%. The table compares and contrasts relative frequency and experimental probability.
Relative frequency and experimental probability similarities. The ratio of the number of favorable outcomes to the total number of outcomes is an experiment. The rule, number of favorable outcomes over total number of outcomes. We have one choice from two choices. So differences, as you see here, describing an event that has already occurred, and here chance of an event happening in the future based on what was already happening. So as you see here, we have two boxes and we open one from two, and here the same idea. Find experimental probabilities. Refer the relative frequency bar graph shown. What is the experimental probability that a person choose at a random from the group will have type A or type B blood? As you see here, we have diagram here. Here we have blood type. We have A and B and AB and O. And here we have the relative frequency from 0 to the 0.5. So what I do, Find the relative frequency of type A or type B. The relative frequency of type A or type B is the sum of the relative frequency of A and the relative frequency of type B. We have here A, as you see here the frequency will be 0.4, and we have here B, the frequency will be 0.1. So add 0.4 plus 0.1. So relative frequency of type A or type B equal relative frequency of type A plus relative frequency of type B. So for A 0.4, for B 0.1. Then 0.4 plus 0.1 will be 0.5. The experimental probability has the same ratio as a relative frequency. So the experimental probability that a randomly chosen donor will have type A or type B blood is 0.5 or 50%. 50%. Find experimental probabilities. A random selection of students in 3 different classrooms was asked the question, what is your favorite season? The results are shown in the graph. What is the approximate probability that a person chosen at random will select spring or summer? So as you see here, we have the seasons, and here we have the relative frequency, the type of the season, winter, spring, summer, and fall. So just we want select spring or summer, I want to from all to try to find the relative frequency, please, just for spring and summer or summer. Start please and tell me what is your answer.
Mr. 53% or 0.53.
Okay, thank you, Lamar. Who has different answer? Okay, listen to me. The first step, find the sum of spring and summer. The separating here, as you see, the height of the bar will be here in this degree. And here we have 0.2, 0.21, 0.22, 0.23, 0.24. So 0.24 plus the summer here, the height of the bar will be here. So here 0.25, 0.26, 0.27, 0.28, and here 0.29, 0.29. So 0.29. Then we can add, we have 0.24 plus 0.29. So the answer will be 0.53. Then find the total. Find the total. The total, you can add the all height of bars. So as you see here, the first bar, here you have 0.1, 0.11, 0.12. So we can write here 0.12 plus, and here 0.24 plus, and here we have 0.29 and the last one here 0.35. Then we can collect. We have 0.12 plus 0.24 plus 0.27 plus 0.35. So the total will be 0.98. Then the relative frequency equal 0.53 divided by 0.98. So we can divide, we have 0.53 divided by 0.98. So the answer about 0.54. Who has any question here?
Yes, sir. When we add the total, yes, sir, it gave me 1 and 0.98.
Repeat your question. When we want to add the total, then?
Yes, sir, the total, Mister, you said it's 0.98, like it's 1.
The total will be 1?
Yes, Mister, I think.
Here we have 0.12. Do you have any problem here?
No, Mister, because I added it and like it gave me 1.
Yes, now revise with me. Here we have 0.12. Do you have any problem here?
No, Mister.
Then here 0.24. It's okay here?
Yes.
And here 0.27. Or here 0.29. Yes, I'm sorry. And here 0.35. Type. I will I will revise we have 0.12 plus 0.24 plus 0.29 plus 0.35. So the answer will be 1. Great, excellent, Lamar. So the answer here will be 1, and here will be 1. So the relative frequency will be 0.53. Is it okay now, Lamar?
Yes, mister, thank you.
Excellent, Lamar. Welcome. Now we have estimate to make reductions. Listen, please.
Estimate to make predictions. Teaching notes. In baseball, a player's batting average is found by writing the ratio of a player's hits to their total at-bats and then writing the ratio as a decimal. The player with the highest career batting average in history had 4,189 hits in 11,434 at-bats. Based on this relative frequency, how many hits can be expected in a season where the player has 500 total at-bats?
As you see here, you have player states, at-bats, AB, and hits H. Here we have 11,434 and 500, and here we have 4,189, and here missing value. Continue with me, please. So what I do, the first step, find the relative frequency ratio of getting a hit. The player with the highest career batting average in history had 4,189 hits and in 11,434 at-bats. So drag the values to complete the relative frequency. As you remember the rule, number of hits over number of at-bats. Who can tell me what is the number here up?
4,189.
Great. And this is the number down. The second step, use the relative frequency to make a prediction. Use the relative frequency to find an equivalent ratio in order to predict the number of hits for 500 at-bats. Let H represent the number of hits for 500 at-bats. So, as you see here, here the same ratio, and here we have the missing value represent H, and here we have 500. So here, who can tell me how to find the value of H? What I do here to find the value of H? We can do a cross product. A cross product. Continue, please. When you do a cross product, the H will be about 128. How? 500 times 4,189 divided by 11,434. Then you can use round 11,434 to the 11,500. Then you can divide 11,500 divided by 500. The answer will be 23. So divide now 4,189 by 23. The answer will be about 182. About 182. In each step, the values were rounded in order to find an approximate equivalent.
Hi, Mister.
Hi. By using ratio reasoning, another possible equivalent ratio called B183 over 500. 183 over 500. So, in a season where he has 500 total at bats, it can be expected that he will have about, who can tell me what is the value here?
$183 or 100.
About 183, exactly 183. Great. Estimate to make predictions. Listen, please.
Estimate to make predictions. Teaching notes. Based on admission records for the last 5 years, a college determines that of the 5,260 acceptance letters they sent out, 4,734 students attended their college. This year, the college sends out 900 acceptance letters. They want to know how many students they can expect to attend.
Okay, I want from all now to read the question again. Then about how many students out of 900 who received acceptance letters can be expected to attend them. Yes, you have 5 minutes, please. Try to find the missing value here and tell me what is your answer.
Yes, sir, maybe 810.
Okay, thank you, Lamar. Who has different answer?
It will be
Right.
840.
Okay, thank you. طيب, listen to me, please. The first step, do estimate for this number. Here we have 4,734. So if you do estimate, will be 4,700. Then do estimate for this number. If you do estimate
5,000?
about 5,000. Then here we
Mr.
have, yes,
Mr. In 4,734, when you make it estimate, it will be 5,000. So why you make it for 1,700?
here we do estimate for the hundredths, or for the tenths. It's up to
Always
you.
you will do like this.
Repeat, please.
Always you will do like this, or just for this question?
Here the question about how many students out of 900 who received acceptance letters can be expected to attend it. So the question not determined the ratio to the rounding. So it's up to you. You can choose round to the nearest tenths or to the nearest hundredths. It's up to you. So here, if you choose the tenths, the right number will be 3, down then 5. So choose 3, remove 3 and 4 and put 2 zeros. So the answer will be 4,700. And here, this is the tenths, and here the right number will be 6, up 5, so add 1 here. So we can here write 5,300. This is one method. The second method, you can do rounding to the nearest hundredths. This is hundredths. And you can do the same idea for the two numbers.
Mr. If we make it thousands, if, 2 of them will be 5,000, right?
You can here write 5,000, no problem, and you can here write 5,000. You can here rounding to the 5,000, and you can here write 5,000. It's up to you, because the answer about nearestly, and here we have 900. And here represent any variable, no problem. For example, n. Here 5,000 over 5,000 will be 1 equal n over 900. Then do a cross product, so n about 900. Who has any question here?
Mr. If we do like the both ways, we will get a correct answer.
Yes, because about, the answer will be about, not exactly.
Okay.
Okay. Okay, this is our lesson today, and this is our period. Inshallah, I will send to you the homework. Let us to take attendance, then you can leave. Aliazia?
Here.
Beka? Sarah? Selma? طيف?
Here, Mr.
عفرة؟ عفرة؟ فاطمة؟
Here.
لمار؟
Present.
ليان?
Here.
Okay. Thank you for your listening. Have a nice day. See you tomorrow, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.
Bye, Mr.